Welcome back to the live stream. If you're catching this live, good morning, good evening, good afternoon, wherever you happen to be watching this. If it's on demand, my name is Rick Claus. I'm your host for the next couple of sessions that are coming on, specifically with regards to building Linux and open source based solutions on Microsoft Azure. I'm joined now by Kundana Paliguri.
Yeah.
Nice to see you again. It's been a while. Last time we met, I guess, was on the MVA platform back in the December timeframe.
Yeah, absolutely. Good to be back here, Rick.
And for those that haven't met you as of yet, can you give us just a little bit of a background about your life here at Microsoft and then what you're going to be talking about?
Sure, yep. So as Rick mentioned, my name is Kundana Palagiri. I'm a program manager in the Azure Compute team. I've been at Microsoft for about 13 years. I've been in various roles, developer, software engineer, and now a program manager. And I primarily work on virtual machine customization and bringing OSS workloads to Azure. Today, as part of this MBA session, we will talk about how to build and accelerate DevOps pipelines in Azure if you are using Linux virtual machines. Now, this is a continuation of what we did last December when you and me. In that session, we primarily talked about Chef, Puppet, and a few other configuration management tools. In today's session, we'll go beyond that. We will actually talk about the entire DevOps pipelines and what are the tools that you can use to bring them to Azure.
Okay. So this is going to be, again, from a technical perspective, talking about the different technologies and capabilities that we have that you're able to install and work with on the Azure platform. We're not going to be going into the whole people, process, and other human aspects of the DevOps concepts.
Absolutely.
There's definitely other courses that are much more better suited.
Yeah. So you're jumping to a slide, my next slide. So if I can go to the next slide.
Yeah. You got it.
So in this slide, as Rick mentioned, we will not talk about the people process aspect of it. We will talk about the tools. We will, give an overview of like what DevOps is, what are the things that fit into the DevOps pipeline, and then the most important thing is we will talk about what are the fundamental building blocks that we are going to use for DevOps in Azure, and what are the tools, like what are some of the Azure provided tools, and what are some of the third-party tools that you can bring for doing DevOps in Azure. And finally, we will be doing quite a few demos. And at the bottom there is the link to the previous session I've put there. So that actually goes a little bit more deeper into a few configuration management tools. That's a very handy reference. Okay.
I was about to say the slides are available for people to go ahead and do a download already if you want to now from the FAQ section if you're watching this live. And if you're watching this on demand from the MVA platform, they're available there as a resource as well.
Okay, great. All right, so let's start up with the definition, what DevOps is. There are a lot of definitions today for DevOps, and I will definitely not be going into defining or giving an overview of what DevOps is, but at a high level to summarize, DevOps is, to some, it's agile administrations, like quick development, quick release. And it's also, automated development and release management process. And it fundamentally is also embraces the philosophy of infrastructure is code, and DevOps is also continuous deployment. In a net, DevOps is all of the above and more. So what we are going to look at today is what are some of the options that Azure provides for doing DevOps and how it integrates with some of the existing technologies that are available for DevOps. So in other words, if you are using Linux virtual machines in Azure, we do not require you to leave all the tools and learn something new. We will show you how you can use those existing tools and how to integrate them with Azure. So here is the DevOps pipeline overview. Again, there are a lot of definitions, but fundamentally the DevOps pipeline includes building the code, developing the code, building and testing them, deploying them, and configuring the virtual machines with these applications, one-time configuration and an ongoing configuration, and finally, monitor what's going on in the environment. And this is a loop, right? So you do this one time, you observe it, you learn, you make changes, and you keep going. And so in terms of tools, we will talk about how Azure virtual machines fit into this DevOps pipeline, how you can use resource manager templates for doing DevOps, a tool called Azure Dev Test Lab, Azure command line interface, Azure diagnostics, and a few other third-party solutions. These are all, we'll see how these, in fact, these are some of our building blocks that we are going to use for looking at the DevOps pipeline.
Now, I'll just interject for one moment to remind people, because obviously working in the IT industry, we use a lot of acronyms. So you might have heard in the previous sessions or other sessions around what we call ARM templates.
Yeah.
The full name for that is Azure Resource Manager Templates. So if you hear the word ARM, we're talking about these templates and where you can find them, what you can do with them, quick starts, that sort of stuff.
Yep.
So use those terms interchangeably, but I love the fact that you actually spelled it out.
Yeah. All right. So then the question is what about Visual Studio, right? When we talk about DevOps, Visual Studio naturally fits in there. But we are not. So Visual Studio offers great set of tools for automated application lifecycle management. But in today's session, we are just going to focus on the tools that you would use normally for OSS workloads. A lot of enterprises is a mix of both Windows and Linux. So many customers might continue to use Visual Studio, which is great. And the link over there in the slide gives an overview of the Visual Studio tools for application lifecycle management. Please check it out. So the next thing, we will talk about the fundamental building blocks that we will use for doing DevOps in Azure. These are core pieces, and it's actually worth spending a few minutes learning about them because everything we do will be built on these things. So these are the Azure Resource Manager templates. Then we have VM images, we have VM extensions, and CLI. These 4 building blocks are used not only for doing DevOps using Azure tools, but these 4 building blocks are used for integrating with third-party tools as well. Okay. So they're very. We'll have to spend a little bit of time talking about these. So let's get into that. We'll start with Azure Resource Manager. Again, the Azure Resource Manager, I will not be getting into details of this. We have a bunch of MVA courses and videos there to learn about it. And I highly encourage our users to learn about Azure Resource Manager templates because this becomes the core foundation for doing DevOps in Azure. But at a very high level, right? So Azure Resource Manager introduces the concept of a resource group. And a resource group is a container that holds all the resources that are used by an application. And the really nice thing about Resource Manager is as an author of that container, you can declaratively specify what is going to be there in your deployment. So it basically uses config as code approach and promotes that by providing reusable templates. And it also provides a unified way for managing and monitoring all the resources that are there in an application. And finally, there is another advantage is it provides a single lifecycle model for the container. This is not all the list of advantages. There are things like you can do rollback access control, you can set tags. But for the purposes of DevOps, the key thing we need to take away is config as code and using declarative templates for repeatable deployments. So over here, I have on the screen a sample template there. We will be looking at a few templates in the next 30-40 minutes.
So that's just JSON templates.
Yes.
Is basically, for those of us that are not like myself that's learning these things, JSON templates just basically a nice formatted text file that allows you to declaratively identify all the different pieces and then be able to go off and
exactly. That's a good point. You call it out. It's a JSON. It's a written JSON language. It's a standard format for declaring your resources. Very easy to read, easy to learn. Okay. So this is the Azure Marketplace. I have taken a snapshot of our Azure Marketplace. So if you go to azure.com and there is a marketplace, if you look at what's there in Marketplace today, you can find hundreds of images that are ready to use. So again, this when we talk about third-party integration, third-party tooling integration, think of it as Marketplace is the door that allows in the third-party tools. By going through this Marketplace, you can find ready-to-use applications that you can get started within minutes. Please take a look at the Marketplace to see what's available today. And then another building block that we will use is the VM extensions. So VM extensions, to those who are not familiar, is a technology that allows you to inject software into a virtual machine, a running virtual machine or a brand newly created virtual machine. So there are two kinds of virtual machine extensions. One extension is, we call them a curated extensions. So this is where Microsoft works with a set of publishers, ISV publishers, to deliver this technology, these solutions for Azure virtual machines. And the next one we have is called custom extensions, where as an end user, you can write your own extension and you can configure your virtual machines. So we'll take a look at both of them. I want to give a quick overview of how this looks. So if you look at the Azure virtual machine, I have on the screen, I have created a few virtual machines. And if I go, let me pick a virtual machine, this one. So if I go here, so this is an Ubuntu virtual machine that's running in Azure today. And when I go here and I click on extensions, I have already added a diagnostic extension to this. But there are a few extensions here that you can add. So basically these extensions, when you say add, this is going to take this software, inject into the virtual machine. So this is a curated extensions. The other kind of extensions that we have is what we call the custom extensions. So in this case, as a user, you can write a template, and the template you can define what kind of extension you want to include. For example, if we go to the template repository and look for, you can find extensions like, I want to take an example of Chef. So here, you can write a template and you can Chef is a curated extension, but you can write, like, for example, LAMP stack or MongoDB. You can install it by using your own templates. So these two, curated extensions, custom extensions. And we have a process for where we work with publishers. If you want your extension to be part of the curated list, we have a process where we can work with publishers and make it a curated extension.
Okay.
All right. Okay. So the last thing, for the last building block that it's very critical and we keep reusing it many times, is the Azure command line. So this is a cross-platform command line tool that is used for provisioning and managing resources in Azure. So if you want to, there are a few ways to install it. There is an installer that's available for Windows, Mac. You can go download and install it. It's also available as a node package manager, or is also available as a Docker container. So if you click on the link over there, it shows you how to install Azure CLI. But on my machine, I have actually already installed Azure CLI. So I'm just going to show you. So the first thing you want to do is Azure login, is how you would enter your credentials for using Azure CLI.
Right.
Now, one thing to
basically authenticating against your Azure subscription to say that you are authorized to manipulate and to work with the resources inside the subscription.
That's correct.
Right.
So one thing to note, as the text over there says, it has to be an organizational account or a service principal. Now, if you want to use your Microsoft account, like, for example, I have a Microsoft account, like Outlook.com, and let me give my password. It fails. So you cannot use your Microsoft account directly to use Azure CLI. Now, to do that, and this is one of the important scenarios that our customers use, they have a non-Microsoft, they have a non-org ID account, and how do they go about using Azure CLI? So I want to quickly show how to do that. So to do that, you would go to Azure, the Azure portal, the current portal, which is go to azure.com, and then click on portal. Okay, it has already logged me in based on, I'm going to log out because I want to do a login using my...
Okay, your different ID.
Yeah, because I want to show this using my different ID, azureoutlook.com. So, and password. Okay, so what I've done is now I've logged in using my Outlook.com, and my goal is to use this for logging in, authenticating you against Azure CLI. So to do that, I have to go to Azure Active Directory. It's taking a little time to load this, but this is Active Directory because I recognize the icon.
Yep, here it comes.
There you go.
So this is the directory associated with your account that
Yes.
you're now showing us right now.
And now here I am going to create a new user.
Okay.
Okay, so this is a new user in my organization. I'm going to call it KP Demo User 2, and it, this is the domain associated with it. Okay, say OK, and some kind of a first name. Doesn't matter for this demo. A display name. Put my name, and I'm going to leave this as this user, the role as a user. All right, and this is now going to give me a temporary password. I'm going to take a note of this long email ID because I most likely will not remember it. So stick it in my scratch pad. Okay, and then it's giving me a temporary password. Copy the password. Okay.
Yep.
All right, say OK. So now we have created a user in this organization. The next thing I want to do is make this user a co-administrator. So if I go to Settings and Administrators and say Add, go to my Scratchpad, get the username, so now this account is a co-admin here. All right, so we are done with this here. Now we need to go and log in as that other account. And when I log in, the first thing it is going to ask me is to change my password because the password that it gave me is a temporary password. So this is the username. All right.
Temporary password?
Yep, this temporary password. Sign in. Okay, when this comes up, okay, I think maybe it's a copy paste error. Okay, there you go.
There we go.
So now give it a real password and log in. So now at this point, you have created an org ID that's associated with your subscription. Now this ID is a co-administrator to your subscription, and it has Azure access.
Right.
So when you go to Azure CLI this time, and you log in, now you log in using those credentials. So not your Microsoft account, but this domain account.
Okay.
Okay, so this is a very important step. Many of our users ask this, so it's important to go through these steps. And again, all of this documentation is available here.
Yeah, at that aka.ms.
Yeah,
it's up to the top.
Okay. So for the purpose of this demo, though, I'm going to log in. I've already logged in as myself. So let me log in as myself, which is my org ID account. All right, so this is the demo that I wanted to show. We just did the demo. So moving on. So now that we've looked at the building blocks, we've looked at the 4 fundamental building blocks that we use. Let's look at how we use them in our DevOps pipeline. So the first thing, we'll talk about the build and test. So for build and test, Azure provides a tool set that ready-to-use tool set that customers can use. For example, some of the most commonly used build tools like Jenkins and TeamCity are supported in Azure today. I have provided URLs there. Actually, if you click on them, it gives you overview of how you can use Jenkins on Azure, how you use TeamCity in Azure. These are plugins that are developed both by Microsoft and by third-party solutions. And
I was about to say, I just want to interject for one moment. If you're watching this on the live stream, the decks are available for download right now. If you don't see the link for the appropriate one, just hit the refresh page. Someone's given me a little tip on that one there to remind me that if it's not available, just hit the refresh and it'll be able to show up as a proper link. And all those lovely long form URLs that you have on there will be able to be clickable by people.
Yeah. Okay. The next thing that we have for build tools is SingleClick Templates. So, we talked about Azure Resource Manager templates. And what we have in our template gallery is a template for setting up Jenkins and a template for setting up GitHub. These are, let me actually show one of these templates. So if I go to the template repo and I go to, quick start templates. And I search for Jenkins. There is a Jenkins on Ubuntu template. So this template, as it can say, this creates virtual machines, and on these virtual machines, it installs Jenkins using custom script extension. Now, previously I talked about your own set of extensions that you can write. This is one example of that. So this uses a generic handler called custom script handler, and it installs Jenkins on these virtual machines. So if you want to look at how this template is authored, click on Azure Deploy, and it basically tells basically it defines all the resources that are used in the template, provisions the virtual machines, and then installs a bunch of scripts that configures Jenkins. So to use this, basically it's pretty straightforward. You can do deploy to Azure.
Yep.
So one additional thing I want to quickly show here is if you're using Azure CLI, Azure CLI not only supports creating virtual machines using imperative APIs, like I can create one virtual machine. It also supports creating virtual machines using the templates.
Okay.
So going back quickly to my grab a command. So what we have here. So this is not right. Okay, so let me grab it.
You just missed, there you go.
I missed the, I have two A's. So this particular commandlet, what it does is, so this commandlet basically creates a deployment, creates a resource group, and what it does is there is in a template gallery, there is a template called 101 Linux VM. This is the most basic template to get started. These are not production ready templates. These are getting started templates. So, it's very, the approach that's recommended is start with this template and then make the changes that you need to make to deploy these applications. So if we go back to our template repo, every template, if you look at it, you need to take the raw URL for deploying. So if you click on raw, grab whatever the URL that's giving us and stick it here. So in this Azure CLI command creates a deployment using this template. And when you run this template, it is going to ask me some parameters, which I'm going to enter. So it is, okay. So basically it says the deployment group is not created. So I'm not going to debug this thing. These are, if I create a resource group that exists, I can get past this error, but I'm going to skip that error to move along. So that is how to deploy a template, existing template. But the second thing is, if I go to this, we have a marketplace. As I mentioned, Azure today has a marketplace. Let's sign out from here and sign in as my org ID this time. So what I'm doing is I'm logging into Azure portal, and I want to show how to deploy enterprise Jenkins image that we have published by working with Cloudbees. So Cloudbees provides an enterprise Jenkins ready to deploy image. So when I instantiate it, I have now Jenkins set up in my own environment. So Azure.com. Go here, and then this is the marketplace partners and marketplace partners. Browse the marketplace, look for Cloudbees. There you go. So this is an image that you can use for deploying a virtual machine. Okay, so this is really great because everything is pre-packaged and it's available in the marketplace. But if you want to create a template, if you want to automate these deployments, and instead of going to the marketplace, you want to deploy them, create a repeatable deployment by using Azure templates, how do we do that? So to do that, we start with our simple Linux demo template, right? So that is my starting template. I make a copy of that, but I need to make a few changes. That simple Linux demo template uses an standard Ubuntu image that's there in Azure Marketplace. But instead of that Ubuntu image, I want to use a cloud-based image. So how do I make the change? And I want to show that because this is, as you think about using more and more of marketplace images and as deploy them as templates, these are the steps that would be repeated. Okay, so what we need to do is we need to identify the image properties. So, okay, so if we go here and Azure VM image. Azure VM image provides a list of Azure commands that you would be using for working with images. So you can see there are a few commandlets, and we have to get the publisher name, the offer name, and the SKU name. Okay, so what I would do is Azure VM image list publishers. Location is West US because that is where I'm going to create. And I know that I am going to look at the image from Cloudbase. So I'm going to just search for that. Oops. Azure VM image list publishers West US and grab Cloudbase. All right, so this should return, okay, see, it found an image called Azure Cloud-based Enterprise Jenkins. The next thing you want to get is the SKUs that are available for this image. So for this, you have to run this command. Again, in the interest of time, I am going to quickly copy paste these. So we have Azure, run the command to grab the SKU that is required. So when you do this, this is the command list SKUs. Okay, so what we need to do is, so I typed the wrong command. Let me quickly come out of this. Okay, so basically, the first step that we need to do, let's do this again because I made the order is not correct. Oops. Azure VM image, okay, cloud-based image, oops. This one, there you go, okay. So we got the image. No, not this one too.
That was the list SKUs when you did there.
Yeah, okay. Oh. So I have to get the offer, which is this.
I think you missed the C.
Oh,
that one there.
Gosh, okay. Our font is a little small to...
Yeah.
Okay, thank you, Rick.
You got it. You got it.
Okay. Well, the commandlet is not working, but you know what? I don't want to spend a lot of time on this. We will have the commands listed in the documentation. But what I wanted to show was by running these three commands, Azure VM image commands, we can grab the publisher name, the SKU, and the offer. Okay. In this case, they all happen to be, enterprise cloud-based Jenkins. So once I have that, what I need to do is. Okay, once I have that, I am going to go to my so what I've done here is I have cloned the GitHub repo and I have downloaded the Linux VM sample template and I have made a copy of that. So in this template, I can use the template as it is, but the only changes that I need to make here are the few changes that I need to make are, let's look at this. I am not using the Ubuntu distro here, so remove that. Okay, and then the next thing is I am going to use the cloud-based image. So what I want to do is you want to add this this property called plan. In this plan is you have to grab the name, publisher, and product. So here the name, publisher, and product map to the publisher's queue and offer that we have retrieved from the previous command. So when you run those previous commands, I did a typing mistake, but if I did not, you would see this output and you stick it in there. And then the other change that you need to do to use the template is the OS profile in the storage profile under image reference, remove the Ubuntu reference that was previously in this template and add the cloud-based template. So what we have done is we have taken a template, a standard template, and we have made a few changes to it to point to the marketplace image and use that image for deploying the virtual machine. Again, just like how we have deployed the virtual machines using CLI, we can use the same command for deploying this. All right, so moving on, right? So what we've seen is, we have plugins for Jenkins and plugins for TeamCity. We have an image published by CloudBees for Enterprise Jenkins, and we also have SingleClick Templates for deploying Jenkins or any other marketplace image. So, from a developer DevOps point of view, if you want to set up your build environment, these few things actually really make it easy to set up these images quickly without having to building up everything from scratch. All right.
Okay.
The next thing, so moving on to lab management. So now that you got the image ready, you have your build environment ready, the next thing you want to do is, run tests on a regular basis. But some of the challenges that with lab management that most IT ops face are creating this shareable test environment. So you want like a single image that everybody uses, and you want to share that in images with a set of people who are working on testing and signing off on those software. You want to also manage permissions on who has access to these images, and most importantly, you want to apply quotas and policies. So you don't want to you want to make sure that you are doing cost management by shutting down the virtual machines automatically at some amount of time. You don't want to exceed a certain image. It's very common, right, when you're doing IT DevOps. You keep creating these virtual machines, and very soon you might be having like hundreds of virtual machines, and you want to put a quota on how many virtual machines can be created. Let's say you can put a quota like, in my lab, so put a quota that only 20 virtual machines can be created. When you exceed the quota, delete the old ones or repurpose the old ones. Such quotas can be applied. So with this in mind, Azure recently released a service called Azure DevTest Lab. So this is a service that allows quick provisioning of environments. It also enables cost management with quotas, policies, and automated shutdowns. And finally, it really provides this shared template mechanism. So one person can be responsible for authoring the templates, and they can share it with the rest of the organization. And the people and the lab users can just instantiate the template to create virtual machines. This is a service that's in private preview. The team is very interested in our customers trying it out and getting feedback. So there are some links over at the bottom of the screen to join the private preview for DevTest Lab. And I want to quickly here show how that looks like. So there is a private URL. Once you are accepted into this private preview, you can actually browse to this DevTest Lab. There you go. So if I go to this service, this will give me access to the private preview DevTest Lab service. And I have already been accepted into this program. So once you go and create, go to Marketplace, say everything. What we have is look for DevTest.
So this is, you've already been accepted. You're just inside the regular portal area right now.
Yeah.
To be able to go in and to look at the dev test environment.
That's right. So if I create a virtual machine, So what I'm creating is not a virtual machine. I'm creating a dev test lab. Okay, and I will give my lab, it's called KP Dev Test Demo. And I can assign the subscription resource groups. I'll accept the standard ones. Pick a region. This is okay. All right. So this is going to spin off a dev test lab for me. Okay, it takes a few minutes, and once this dev test lab is ready to use, I can. It takes a couple of minutes. I can then, create templates that I can share with users. I can add users who have access to this lab. And when those users log in with their credentials, they can see this lab, they can see all the environments that were pre-provisioned for them. Let me come back. This takes a couple of minutes. I will come back to the dev test lab and show the user experience of the dev test lab. But for now, the links over at the bottom of the screen shows you how to, there is a talk that was delivered at Build Conference that gives an overview of the dev test service and the URL for joining the private preview. All right, so that was the dev test lab. So we're next moving on in our DevOps pipeline. We talked about building, we talked about testing. Then the next thing is deploying and configuring. So you have your build artifacts that you generate. Now, how do you go about deploying these to Azure virtual machines? Of course, the first place always is the templates. Templates can not only create virtual machines, templates can also deploy software onto them using the extension model, right? So that's always one way there. So if you look at it, what is the fundamental, some of the core principles for configuration and customization. So one of our the goals that we have is always support config as code deployment model. We enable that using Azure Resource Managers and extensions. We also in this space allow users to bring existing tools like Chef, Puppet, SaltStack, that they use in any other cloud, on-prem cloud or private cloud, and use it in Azure. And then there is a consistent, the big benefit that our users see is there is a consistent experience for managing both Azure public cloud and Azure Stack-based private cloud using these tools. My dev test demo is actually, lab is up. So let me quickly show on the screen. So here, if you can see, I have a dev test lab. On here, I can do settings like templates. So it already comes with a few templates. Okay, and these are the templates that the lab users can use. I can create more templates here. And it comes into this private template gallery. And these templates, as an administrator, I define like the settings of the templates, and I can make it available. And the next thing is I can allow which users have access to what, who are going to be my lab users. So these are, so there is here you can select a role called lab user. You can select a user, like I have my other non-org ID account that I'm going to use. Right, it's gonna, so this account is going to be user. So today this does not support the quotas or managing the cost, managing the budget, but those are the features that are in pipeline for this service.
Oh, okay.
All right. Okay. So now going back to config management. So we have a few options, right? So we have a custom script extension as a primary way for config management. We have Chef, Puppet, and other config management solutions. Quickly talk about custom script extensions. So this provides a way to author scripts, upload them to a GitHub or a storage account, and then deploy them to a running virtual machine. So the previous MBA talk goes in depth about custom script extension. Please look at that if you want additional details. I also want to show a quick demo of custom script extension. So over there, these are sample templates that were all written using custom script extension. So whether it is deploying Apache Server or MongoDB, Tomcat, if you look at, I want to open just one of these to quickly show how this has been authored. So if I look at Tomcat, so this is my template, And in this template, a standard template where I'm taking a bunch of parameters for creating the VM, and I'm also taking parameters for specifying which version of OpenJDK I want, which version of Tomcat package do I want to install on the VM. And then when you go down all the way to the virtual machine section. So here is where we are creating virtual machine, but within that there is a section called extension. So here I'm specifying that once the virtual machine has been created, install the custom script handler and run these scripts. So these scripts, which are also available in GitHub, installs Tomcat and installs JDK. So this is an example of how you can use custom script extension to do your own configuration inside a virtual machine. So the next thing we have for configuration management is using third-party tools like Chef, Puppet, SaltStack. These are the ones that have been supported for a while, and in the last 6 months we have provided a lot of enhancements to make the scenario more end-to-end and complete. So to start with, we have for Chef, we have now we have a Chef server image in Marketplace. So what it does is basically there is a SingleClick deployment template for deploying Chef server in Azure. So if you've deployed Chef server yourself, you might realize that there are a few configurations that are needed for deploying Chef on Azure. But with this image, it takes care of everything. It's almost like a single-click deployment. So if I go to Chef in the Marketplace, I can see this. So this is my Chef server. Give it some parameter, give it the standard parameters like the VM name, the host name, and the password. Okay, so let's say the host name, kp chef server demo 2. Username for SSH and password. And then you select the pricing. I'm going to go with the default recommended. A resource group, I'll stay with that, and location. Okay, so I am not changing any of the parameters, and I say create. It asks me to provides information to buy this. In this case, this is this image up to I think 20 nodes is free, so you are not paying anything to use Chef here. So just say buy. As it says, it doesn't cost anything here because this image supports bring your own license. So up to 20 nodes, it is free of cost, and all of that information is available here. And if you go beyond that, you can bring your own license for Chef server.
Yeah. And again, this is just the standard disclaimer page that comes up with any of the images that I've noticed.
That is true.
Have them in there.
That is true. So what's going to happen is it is going to create a Chef server. It takes a few minutes again. It is spinning off the virtual machine, doing all the configuration that's required for configuring Chef server. But I have previously created another Chef server that I want to SSH to. Okay, let's see. And the name of this Chef server is kp chef server demo. I'm gonna grab this. Oh, what happened? Oh, not in this one, sorry. I have to go here. Too many windows.
Yeah.
All right. All right, so there you go. It's asking me to provide the password for the Chef server. So this is an image that I provisioned last night. It has Chef server installed on it. Now I'm logging in for the first time. When I log in for the first time, it's asking me to run this command. So what this command does is it creates an user to manage that Chef server, and later I can use that user account to log into that Chef server. So as you can see, right, like all of the operations that are required to set up Chef server has been like condensed into 2 steps. Take the image, spin it off, create a virtual machine, SSH into that image, and create a user account. So let me just go ahead and do that. Chef setup, username, Chef server user, and password. they also recommend that Chef also recommends that is a temporary password. Once you log in, put a more password that meets the requirements. And then license agreement, yes. So this is going to create a user account on the Chef server. I have created another. All right, let me go quickly to this one. I don't need this. Close window. Don't save. Okay, so I have created previously a Chef server that I want to browse to. So this was also created using the same steps. The username and the password. I don't normally keep my passwords in Notepad. This is just for the demo. All right. So this has created, a Chef server. Actually, it's a few steps. Now, once the Chef server has been created, the next common thing that most users would do is creating a virtual machines and configuring them as Chef clients. And creating that configuring that Chef client requires this Chef server URL. And this is a two-step thing, right? Set up the Chef server, grab the Chef server URL, and provide it as input for creating Chef clients. So there are a couple of ways to create a Chef client. One is you could do it from portal. If Chef is an extension, we've seen that. So you can go with that approach. You can add an extension and provide the Chef server URL as input. Or you could go to the template route. So if you go to the templates again, we have a Chef template that we're going to look at it. So this Chef template, not this one. Going back to this template Chef. This template. So here in this template, this is a template that installs provisions a virtual machine. Okay, and adds Chef as a parameter. So if I go down, all the way down, okay. So here, so this template declaratively specifies that after provisioning the virtual machine, install the Chef extension, provide the node name and the Chef server URL and the validator name. So all of these input will be available once by logging into the Chef server. So I can select the node and I can download a starter kit. So when I download this starter kit, it is going to give me the certificate and other credentials that are required for setting up Chef. So to recap the Chef scenario, right? So we have not only now single step deployment for Chef server. You can also extend it to creating Chef agents on the virtual machine. In addition to that, Chef has provided additional integration options like the tooling options. So if you're a Chef user and if you've used Azure, Knife is the provisioning tool for Chef. You can use that to provision virtual machines in Azure and install Chef extension on them. And finally, Chef provisioning is a tool which is very similar to Azure Resource Manager. It creates a bunch of resources in any cloud that you provide, and you can use Chef provisioning to provision virtual machines in Azure. So moving on quickly. So we also have an integration story with the Puppet and SaltStack as well. So the link over there gives a Puppet to Puppet steps, and there is a SaltStack image in Azure Marketplace. The last thing is monitoring. So for monitoring, basically our goal is to provide, inbuilt monitoring solution that comes when you provide a virtual machine, and that can be used for monitoring the infrastructure. We also provide seamless integration for third-party tools like Datadog, which is a Linux monitoring solution. It is done using extensions and templates. So quickly to show how the Azure monitoring solution works. So when you create a virtual machine, you can enable the option. So let me quickly show you. So create a virtual machine, select Ubuntu, host name for this. Okay. KP monitor, and username and password. And then if you go here, you have this configuration called diagnostics. When you go to diagnostics, you can say turn on diagnostics. So what it is doing is this is going to create a storage account on behalf of you, and it is going to collect all the diagnostic information from the virtual machines. This is logs, performance data, and other kind of events that are coming on the virtual machine. And it takes all of this information, and it on a periodic basis it uploads it to the Azure storage account. And the Azure portal here collects all of that information, and it presents it lets you view what's going on in your infrastructure. So I have let me show you a VM that I have already created with diagnostic extension. It's probably this one. Yeah, so as you can see, right, so this information about like the CPU usage, the disk usage, etc., is coming from the virtual machine, and that's being collected by that extension. I can do additional settings on this by I can set alerts. So when the usage hits a certain threshold, I can actually trigger some kind of alerts, and these alerts can send emails, etc. I'm going to skip, you can set metrics for alerting, etc. I'm going to skip all this. But the idea is this extension is provided by it's free of cost. It's available for all virtual machines. You can enable it using the standard DevOps tools that we looked at it, right? You can Azure CLI, templates, portal, any of these can be used for deploying this. An additional solution that we have is Datadog. Datadog is monitoring, third-party monitoring solution that's available as an extension. So if I go here, and an extension, there's Datadog for Linux. So basically, this requires a bring your own license scenario. So you need to sign up for a subscription there and add the Datadog extension, and then it starts monitoring the virtual machines, and it lets you generate reports on what's going on, reports on what's going on with the VM. So this is at a very high overview of the monitoring story and at how it fits in with some of the DevOps tools that we have provided. I think that pretty much wraps up the whole DevOps talk. So this, as a summary, I want to emphasize that the concept of code as config is built as part of the DevOps best practices. And we also have not only provided the first-party tooling, which the resource manager templates, which I encourage you all to take a look at it, but we also have a flexible model for providing rich integration with some of our own first-party tools and third-party tools for managing DevOps pipeline in Azure.
I was about to say it's definitely progressed a lot further than when we saw it for the first time back in the December timeframe.
Yes, yeah.
It's much simpler as far as a one-click deploy, and then those templates, those quick start templates, definitely make a big improvement on the deployment environment for sure.
Absolutely, I think this is a very exciting space. Actually, we are very proud as a team to see how far we've come, and I'm really our goal is to support many of the existing tools out there and make it really easy to work with Azure.
I think that's about it. That's all we have time for today, but thank you very much, Kundana, for coming down again.
Yeah, thanks again, Rick.
You coming down. We'll be right back after a very short break, and I believe Ross is going to be dropping by and talking about some container technology.
Yep, very exciting.
Work on Azure. So stay tuned. We'll be right back. Thanks a lot for joining the session.
Thank you.